All right, you guys. This is the last week. We finally arrived. It's the last week of Chem 107 lab. And first off, before we get started on the lab, I just want to say that the first part of the semester was rather enjoyable. I liked meeting you all, and thank you for working hard in the class. The last part of the semester is what it is. I'm sorry that I'm not there to say goodbye to you guys in person, and that's just the way it has to be this time. If anybody would like to stop by and say hi in the fall, feel free. My office is just down the hall from the Chem 107 lab. And if you take Chem 108, I share an office with the Chem 108 instructor, so maybe I'll see you if you come to office hours. Okay, so let's get started with experiment 14, excuse me, chemical equilibrium, or this is really all about what we call the Chatelier's principle, okay? The Chatelier's principle, I assume you guys have covered this in lecture, just simply says if something is at equilibrium and we disturb it, it will go back to equilibrium. So let's talk about that really quickly. I'm going to scroll through all this just to get to a blank page. I'm going to kind of come back to some of this stuff in a minute. Here we go. So what I want to talk about is what we call the common ion effect of Le Chatelier's principle. And the common ion effect is just when we add, there we go, adding an ion to a reaction that appears in the reaction. Okay, so let me give you an example, and I'm just going to use an example from the lab since that would certainly be easiest. So we have this cobalt complex. We're not going to worry about the chemistry here, it's a bit complex. We're just concerned with the reason we use this equation or this reaction is because it's colored. Okay, so we have cobalt hexahydrate ion plus 4Cl minus, and it is in equilibrium with the cobalt COCl4, let's say it that way, COCl4 2 minus ion, and 6H2O liquid. Okay, now what we're going to do is we're going to add a common ion. And it's going to maybe not look like a common ion at first. We're going to add NaCl. This isn't what you're doing in the lab exactly, but the idea is the same. So we're adding NaCl. Well, NaCl does not appear anywhere in this reaction. If you look, you won't find it. But NaCl gives us Na plus and Cl minus. Now, if we look, there's no sodium in the reaction, but there is Cl minus. Obviously, it's right there. Okay. So when we add Cl minus, we're adding what we've added in the reaction. They have a common ion or an ion in common. That's where we get this term common ion effect. Now, what exactly does adding that Cl minus do? Well, it's pretty simple if we follow through step by step. Okay. So adding the Cl minus, we increase the concentration of Cl minus. And I assume you guys have talked about the square brackets, and square brackets just means concentration. There's our concentration. So when we add Cl minus, we increase the concentration of Cl minus, which in turn increases collisions between CO, H2O, 6,2 plus, and Cl minus. Remember, if we just add something, if we increase the concentration of something, it's more likely to collide with what else is in there. So when we increase collisions, that makes a reaction more likely, and we increase the forward reaction rate. And what does that do? Well, that shifts our equilibrium. And we can say it shifts it forward, and it shifts it to the right, or we can even say towards products. I don't really care which one of those three you choose. They're all the same thing. It's, whoa, hello. Sorry about that. If we add Cl minus, we're shifting this reaction forward, and that's why, that's supposed to be an arrow. That's why the reaction changes color. Okay. So let's talk about the uncommon ion effect. I've actually never used that term, but in the video, the instructor that made the video uses that term a lot. So we'll use it. Uncommon ion effect. Okay, it's just what it sounds like. We're adding an ion that reacts, or that does not appear in the reaction. Not appear in the reaction. And you might say, well, if it doesn't appear in the reaction, how could it possibly affect the reaction? Well, we'll see that in a second. Okay. So here we go. Another example from your lab. HC2H3O2 aqueous plus H2O liquid gives us C2H3O2 minus aqueous plus H3O plus aqueous. Okay, so here what we're going to do is we're going to add, again, an uncommon ion. Let's add NaOH this time. Okay, we don't see NaOH anywhere in here, but NaOH does break down into Na plus and OH minus, so do we see those? Well, no. But you might notice something. This guy and this guy will react together. Okay, so if they react together, we know that that will have an effect, because OH minus aqueous plus H3O plus aqueous gives us 2H2O liquid. Okay, so what does that in effect do? That reduces the concentration of H3O plus. Okay, so that slows the backwards reaction. Slows the reverse reaction. So therefore, relatively speaking, that backwards reaction is going slow compared to the forward reaction. And again, this shifts to the right. Okay. Or forward, or towards products. Okay, again, that's not always going to be the case, but in this case it was. So let me go through and kind of step you through this lab really quick. The instructions that are given in the lab manual, or I'm sorry, in the video, there's a lot of detail there, so I'm going to let you kind of use those too. There we go. This side is blue. This side is pink. Why is this not working? I don't know why my pen is not working suddenly. Okay, anyway, that's one side's blue, one side's pink. Oh, now it's working if I touch it. This is, hello. Okay, last video, let's just get through it, shall we? So one side is pink, one side is blue. So when you look at the reaction in the videos, it actually is pink or blue. And so if it goes from pink to blue, we know which way it shifted. We know it shifted this way. But if it goes from blue to pink, we know it shifted this way. So use that to answer those questions. Okay. This one is a little bit trickier because, oh, wrong color. One side of this reaction is actually clear and colorless, but we're going to add an indicator dye. And the indicator dye is not the shift you're looking for, but the indicator dye is going to turn this side red and this side yellow. And it's all going to be mixed up together, so it's just going to be orange. But if the reaction shifts to turn more yellow, it's going that way. If it shifts to turn more red, it's going that way. So again, use that to answer those questions. Okay, same thing down here, except for this side is pink, and this side is clear. Sorry, I don't have a clear pen. It was supposed to be black. This is clear and colorless, okay? So if it's shifting towards clear and colorless, it's going that way. If it's shifting towards pink, it's going that way. And same thing here. We have tan and blood red here, okay? If it's shifting towards more dark red, it's going that way. If it's shifting towards more tan, it's going that way. Oh, there was one up here. I'm sorry, I forgot. Where'd it go? Oh, it's down here. Oh, gosh, I'm all over the place. I'm sorry. Then this last one, might as well do it while we're here. There is no color, but take note of the phase. Solid, aqueous, aqueous. So one side, everything is aqueous. The other side, you get a solid. So if you see a solid appear, hint, hint, you know which way the reaction is going. If it's going to solid, it's going that way. If it's going from solid to aqueous, it's going that way. Okay, let's scroll through this. Now, I didn't talk about this, so I want to answer it. Heat. Write the reaction above, including heat. Okay, you see that right there? If the reaction is exothermic, heat is a product. And you just literally write the word heat as a product. Okay? If the reaction is endothermic, meaning it absorbs heat, heat is a reactant. Okay, that should do it for this lab. Just go through and answer the questions. Like I said, the video has a lot of detail. And once again, I just want to say thank you guys for a good semester. I hope you have a good summer, and I hope we all can get back to Chico State and have in-person classes in the fall. And I would love it if you guys wanted to come say hi to me in my office sometime. So take care and have a good summer.